Mastering data virtualization. Data virtualization upends traditional data integration approaches with its revolutionary methodology. Where does the implementation of data virtualization stand in relation to traditional data integration approaches, and in what ways does its unique methodology set it apart from these conventional methods? The quiet revolution of data virtualization. It's a topic that gets me thinking back to a project I worked on with a large financial institution. They were drowning in a sea of data, with siloed departments and duplicated efforts. It was like trying to navigate a puzzle with missing pieces. That's when I knew we needed a game changer, a way to unify their data landscape without creating another massive, expensive IT project. I recall sitting in a conference room, surrounded by skeptical stakeholders, trying to convince them that our approach wasn't some pie-in-the-sky fantasy. We needed to tame the data beast, and fast. I thought to myself, how can we make this work? How can we bring together disparate systems and make them talk to each other without boiling the ocean? That's when the light bulb went off. What if we didn't have to move the data at all? Data virtualization, in all its glory, stepped into the spotlight. By creating a layer of abstraction, we could leave the data where it lived and still present a unified view to the business. It was like watching a symphony unfold, each instrument playing its part, yet the conductor, the virtualization layer, ensured harmony. Now, I know what you're thinking, but what about performance? Ah, my friend, that was the beauty of it. By not having to physically move data, we avoided the ETL, extract, transform, load, bottleneck. It was like unshackling the data from its traditional chains. Suddenly, the business could ask questions and get answers in near real time. Of course, there were still the naysayers. The "we've always done it this way" crowd, who feared change like the plague. I recall one particularly tense meeting, where a senior stakeholder asked, "But how can we trust this virtualization magic?" I smiled, took a deep breath, and said, "Let me show you." I drew a simple diagram on the whiteboard, illustrating how the virtual layer connected the dots between systems. The room fell silent, as eyes widened in understanding. It wasn't a cakewalk, mind you. We encountered our fair share of speed bumps. There were the technology hurdles, like navigating the complexities of metadata management. And then, there were the people hurdles, convincing departments to relinquish their data fiefdoms. I remember one team lead, who was fiercely protective of their data, saying, "You're taking our power away." I listened, empathized, and explained how this new approach would empower them, rather than diminish their role. Fast forward to today, and that financial institution is thriving. Data virtualization has become the lifeblood of their organization, fueling business intelligence and customer insights. They've reduced costs, increased agility, and have a newfound appreciation for the value of their data. As I look back, I realized that data virtualization wasn't just a technical solution, it was a catalyst for cultural transformation. It required imagination to envision a different way, moral courage to challenge the status quo, and negotiation skills to bring everyone along on the journey. In the end, we didn't just implement a new technology, we created a new narrative, one where data became a unifying force, rather than a siloed, fragmented mess. And that, my friend, is the true power of data virtualization. The implementation of data virtualization stands in stark contrast to traditional data integration approaches, offering a unique methodology that sets it apart from conventional methods in several key ways. Conventional data integration approaches, such as ETL, extract, transform, load, typically involve physically moving and transforming large amounts of data from multiple sources into a single, unified repository. This approach can be time-consuming, resource-intensive, and often results in data latency and inconsistencies. In contrast, data virtualization adopts a radically different approach. It does not require the physical movement of data. Instead, it leaves the data in its original location, providing a virtual representation of the data that can be accessed in real time. This approach enables organizations to create a single, unified view of their data without having to replicate or move the data, thereby eliminating the need for data warehousing, ETL, and other time-consuming and resource-intensive processes. One of the primary ways in which data virtualization sets itself apart from traditional data integration approaches is through its use of abstraction. Data virtualization employs a layer of abstraction between the data sources and the consuming applications, providing a virtual view of the data that can be accessed and manipulated as if it were a single, unified repository. This abstraction layer enables organizations to create a unified view of their data without having to physically move or transform the data, thereby reducing the complexity and costs associated with traditional data integration approaches. Another key differentiator of data virtualization is its ability to provide real-time access to data. Traditional data integration approaches often involve batch processing and data replication, which can lead to data latency and inconsistencies. Data virtualization, on the other hand, enables organizations to access and manipulate data in real time without having to wait for batch processing or data replication. This real-time access to data enables organizations to make faster, more informed decisions and respond more quickly to changing business conditions. Data virtualization also enables organizations to create a more agile and flexible data infrastructure. Traditional data integration approaches often require significant upfront investment in hardware, software, and personnel, which can make it difficult to adapt to changing business conditions. Data virtualization, on the other hand, enables organizations to quickly and easily create new data views, add new data sources, and modify existing data views, without having to make significant investments in new hardware, software, or personnel. Moreover, data virtualization provides improved data governance and security. Traditional data integration approaches often involve creating multiple copies of the data, which can lead to data inconsistencies and security risks. Data virtualization, on the other hand, enables organizations to maintain a single, authoritative view of their data while still providing secure, controlled access to the data. This reduces the risk of data breaches and inconsistencies and enables organizations to meet regulatory compliance requirements more easily. In addition, data virtualization enables organizations to reduce their data management costs. Traditional data integration approaches often require significant investments in hardware, software, and personnel, which can be costly and time-consuming. Data virtualization, on the other hand, enables organizations to reduce their data management costs by eliminating the need for data warehousing, ETL, and other time-consuming and resource-intensive processes. Finally, data virtualization enables organizations to create a more scalable and flexible data infrastructure. Traditional data integration approaches often involve creating fixed, rigid data structures that are difficult to modify or adapt to changing business conditions. Data virtualization, on the other hand, enables organizations to create a more scalable and flexible data infrastructure that can quickly and easily adapt to changing business conditions without requiring significant investments in new hardware, software, or personnel. In conclusion, the implementation of data virtualization stands in stark contrast to traditional data integration approaches, offering a unique methodology that sets it apart from conventional methods in several key ways. Data virtualization's use of abstraction, real-time access to data, agile and flexible data infrastructure, improved data governance and security, reduced data management costs, and scalable and flexible data infrastructure make it an attractive alternative to traditional data integration approaches.